This presentation of diagram is the series circuit RLC in electrical AC system, a combination of resistor, an inductor, and a capacitor. I created this software for better presentation for you. Previous lessons we discussed what is pure resistor, a pure inductor, and a pure capacitor. Let us refresh our lesson. This is a pure resistor. The voltage and current are in phase. The power factor of 1. The electrical power is fully consumed by the resistance. As a result, none of the electrical power is returned back to the source supply. As shown in this waveform, is above the horizontal axis. This is a pure inductor. The current lags voltage by 90 degrees. Has a 0 lagging power factor. As shown in this waveform, the maximum and minimum power are exactly the same, which means that the inductor is returning energy back into the circuit. In a pure capacitor circuit, the current leads the voltage by an angle of 90 degrees. The consumed power in pure capacitance is 0, as the power absorbed and returned back during each half cycle. You can see this instantaneous power waveform that alternates equally between positive and negative. Let us proceed our lesson about a series RLC in alternating current circuits. We enter the value of 10 ohms, 0.01 Henry, and 100 microfarad. Increase the value to 20 ohms, 0.05 Henry, and 150 microfarad. Try to observe and understand that the load power is increased. Increase to 50 ohms, increase to 0.1 Henry, and reduce to 20 microfarad. Change the value, and please observe the waveform, and understand the calculation. Again, change the value to 12 ohms, 0.15 Henry, and 100 microfarad. Now, enter the final value to 20 ohms, 0.20 Henry, and 200 microfarad. The impedance of 51 ohms, and the result of current, is 4.5 ampere, and the true power of 406.74 watt. Increase the resistance of the resistor load to 200 ohms only, and observe the circuit. The impedance is increased to 205.5 ohms, the current is reduced to 111 ampere, and true power to 250.7 watts. Again, increase the resistance of resistor to 400 ohms. The impedance of 402.7 ohms, the current of 0.571 ampere, and the true power of 130.45 watts. We set slowly, increasing the resistance value from 20 ohms to 400 ohms. Please observe the calculation. As you notice, if increasing the load resistance of the resistor, and remain the same value of inductance and capacitance, you can see, in the calculation, the load impedance is increasing, while the current and power is decreasing. The power factor is increasing to 1. It means that the voltage and current are nearing the phase angle of each other. Now, you clearly understand the result if you increase the load resistance. For more understanding, we set slowly, decreasing the load resistance of the resistor from 20 ohms to 2 ohms. You noticed the load impedance and the true power is decreasing, while the current is increasing. The power factor is reducing to zero. It means the voltage and current are nearing out of phase each other. For next lessons, we double the load inductance value of the inductor only, from 0.2 Henry to 0.4 Henry. The value of resistor and capacitor is remain the same. Please observe this result. The result of impedance is 111.5 ohms, the current of 206 ampere, the true power of 85.01 watts. Again, increase the value of inductance to 1 Henry. The result of impedance is 298.9 ohms, the current of 0.769 ampere, the true power of 11.84 watts. Much better, let us repeat the calculation. If we set slowly, increasing the value of inductance from 0.2 Henry to 1 Henry. Please understand and observe the waveform. You notice, if increasing the inductance load, the result of impedance value is increasing, while the result of load current and load power is decreasing. We set slowly, decreasing the value of inductor from 0.20 Henry to 0.02 Henry, and observe the calculation. As shown in the program calculation, the impedance value is decreasing, while the current is increasing, and the load true power also increasing. The power factor is increasing to 1. It means, if the inductance value is reducing, the circuit will become a resistive load. As shown in this power waveform, is slowly approaching above horizontal axis. Now, you learn how inductor behaves in electrical RLC circuits. We proceed to the capacitor load, increased to double by 400 microfarad. The result of impedance is 58.4 ohms, the RMS current is 3.94 ampere, and the load true power is 310.15 watts. Again, increase value of capacitor to 800 microfarad. The result of impedance is slightly increased to 62.15 ohms. The load current is decreased to 3.70 ampere, and the real power is reduced to 273.83 watts. For clear understanding, we perform the calculation. If slowly increasing the value of capacitor from 200 to 800 microfarad. Please observe the graphically waveform. As you can see on the screen, the value of impedance is increasing, the result of current is decreasing, and the real power is also decreasing. The power factor is slightly decreased from 0.39 to 0.32. It means the voltage and current are going out of phase each other. Let's do again. Set slowly decreasing the value of capacitor from 200 microfarad to 20 microfarad. And please observe the calculation, and must understand. The value of impedance is decreasing, while the current and power is increasing. The power factor is increasing. It means the voltage and current are going in phase each other. That's our presentation for today. Thank you for watching. Please don't forget to subscribe and click below.